Welcome to the flight deck for today's explainer. Okay, let's just dive straight into this, because today we are tackling a really high-stakes scenario that absolutely every aviator has got to master. I want you to picture this, student pilot. You're at the controls, the engine is humming, but beneath your wheels, well, it isn't the comforting, predictable grip of pristine asphalt. Nope, instead it's thick mud, deep snow, or really wet, spongy grass. So what actually happens when your aircraft's wheels hit that kind of terrain? Well, the normal physics of flight and ground movement are suddenly thrown right out the window, and your margins for error, they shrink dramatically. So today, we're going to learn exactly how to conquer these conditions.
So let's start by defining exactly what we are dealing with. A soft field isn't just a patch of dirt. According to our flight manual, it's any area with a soft surface, like sand, snow, wet grassy surfaces, or even just distinctly rough terrain. And you've got to understand the physics implied here. These surfaces create significant, and I mean significant, extra frictional drag. They literally grab at your tires. They put immense stress on the wheels, drastically degrading your acceleration during a takeoff run and increasing your deceleration during a landing roll. The fundamental danger here is that your wheels have a severe tendency to dig in, which, let's be honest, can ruin your day in a real hurry.
All right, Captain, here is our flight plan for today's lesson. We'll brief the soft field mission, cover taxiing without getting stuck, execute the takeoff, master the landing, and finish up with parking and our debrief. Let's get to work.
Section 1. Briefing the soft field mission.
You know, a truly successful maneuver starts before we even turn the ignition key. Just picture our operating environment for a second. Imagine a Cessna resting on a grassy, uneven surface. The absolutely crucial point here is this. Your primary golden rule for soft field operations is weight transfer. When operating from a soft surface, you want the wings to support the weight of the aircraft for as long as possible. You must keep the airplane's weight off those wheels because, as we established, they desperately want to dig into the earth. Your entire goal here is to transfer the weight from the wheels to the wings as soon as possible, achieving the absolute shortest ground run possible. But hey, before we commit, we must evaluate. As with any airport, you never just roll onto a soft field hoping for the best, right? You run your pre-field evaluation checklist. First up, verify the wind direction. Second, evaluate the surface condition and its overall length. Now keep in mind, takeoffs are going to require more distance than usual because of all that extra drag, and landings will actually require less. Finally, check for obstructions or hazards in your takeoff and approach paths. While for today's specific lesson we are assuming a nice, long surface with no obstacle clearance problems, you absolutely must verify this in the real world before proceeding.
Moving right along to Section 2, Taxiing without getting stuck. Moving a metal machine weighing thousands of pounds through mud or soft grass, well, it feels incredibly sluggish and it requires a completely different mindset. In a normal taxi environment, you just casually taxi out, find a nice spot, stop the aircraft, and run through your engine run-up and pre-takeoff checklists. But on a soft field, stopping literally means sinking. You must try to avoid stopping on the soft surface at all costs. You complete your engine run-up and your pre-takeoff checklists before you ever taxi onto the soft surface. Once you transition onto the grass or mud, you keep rolling at a speed consistent with safety. If you stop, those wheels will sink and your flight will be over before it even begins.
Section 3. Executing the takeoff.
Okay, this is the climax of our departure where we really ramp up the energy, so stay with me here. Picture the runway ahead. We are rolling out, we are aligned, and remember, we never stop moving. Step 1. Smoothly apply maximum power while holding the control column fully back to keep the weight off that nose wheel. Check your engine instruments. Make sure maximum power is actually delivering. Step 2. Lift the airplane off the ground as soon as possible. We want to lift off at a lower speed than a normal takeoff. Step 3. The very moment you are off the ground, level off and accelerate in ground effect close to the surface.
We have to apply elevator back pressure immediately to raise the nose wheel off the ground. We lift off at an early stage. But, and this is a big but, we don't just climb into the sky immediately. We accelerate in ground effect. Because the airplane can actually fly in ground effect at a lower speed than when it's well away from the ground, you do not climb more than about 10 feet above the surface until a safe flying speed is attained. It's this incredible floating sensation, skimming just above the grass, letting the physics of the air cushion build your speed before you initiate a true climb-out.
Once you initiate that climb, you've got to watch your gauges like a hawk. If you used flaps for the takeoff, you hold the recommended obstacle clearance airspeed. Hold VX, the best angle climb airspeed, until all obstacles are completely clear. And listen to me carefully on this one. Because these low speeds are so close to the aircraft's stall speed, do not fly any slower. Your strict speed tolerance is +5 -0 knots. Once you clear the obstacles, you can finally accelerate to VY, the best rate climb airspeed, raise your flaps at a safe altitude, and take a breath.
Okay, Section 4, Mastering the Landing. We've successfully flown our mission. Now we must dramatically slow things down mentally and physically. Let's review our touchdown goals. Extending full flaps will reduce your stall speed, allowing for a very low-speed touchdown. You want to maintain a prolonged float with the nose held up higher than normal. You're looking for a minimum descent rate with absolutely no drift. But the most critical instruction here, the absolute golden rule of soft field landings, do not use your brakes. Brakes are usually not required because the soft surface acts as its own brake. It will naturally drag you to a halt. If you hit those brakes, you put severe stress on the landing gear, and you will almost certainly cause the nose wheel to violently dig right into the dirt.
Let's walk through the exact sequence. As you flare, you might even leave just a little power on to maintain that high nose attitude, to extract the maximum airspeed loss out of the flare. Touch down smoothly. And the absolute moment those main wheels touch the grass, hold back elevator. You must keep that fragile nose wheel off the soft surface for as long as possible as you roll. Only when you lose elevator authority do you gently let the nose wheel lower to the ground. Use your rudder for directional control and just let the terrain bleed off your speed.
Section 5, Parking and Debrief.
The aircraft is intact and the nose wheel is clean. Now, as you finish your landing roll, you might actually need to add a little power toward the end just to keep the airplane moving so you can taxi to the parking area without getting bogged down. But here is the final pro tip. If possible, park the airplane on a hard surface. Do not leave it sitting in the mud or soft grass, or it might just sink under its own static weight while you're gone, making the next flight's taxi out an absolute nightmare. Once on the hard surface, complete your normal shutdown checklist and secure the airplane.
Excellent flying today, Captain. Now let's head into the briefing room and pull up the Flight Manual's Chapter 41 review to see exactly what stuck from today's lesson. We covered weight transfer, ground effect, and those incredibly strict airspeed tolerances.
But I want to leave you with question number 2 from our manual. It's the core physics problem that basically defines everything we did today. When operating on a soft surface, what is the exact risk for the wheels? If you can instantly answer that they have a severe tendency to dig in, creating dangerous frictional drag, then you understand exactly why we transfer the weight to the wings. But what happens when that soft, muddy runway is also incredibly short and maybe has 50-foot trees at the end of it? Well, that requires a whole new set of skills. Keep that in mind next time you look down at a wet grass runway. Thanks for joining me on this explainer, and I'll see you in the skies.